Hi everybody, today we're going to get ready for tomorrow's class lesson by talking about some common angle relationships. Now the really good part about the lesson that we're going to be doing tomorrow is a lot of these angle relationships we talked about already on Monday and Tuesday. So this is kind of a refresher and going a bit more in depth on some of those relationships. So the first relationship we're going to talk about is when we have a bunch of angles coming out of the same vertex point. So if you take a look at the diagram here, notice how we have one vertex point and we have a bunch of angles that are coming out of this vertex point. We have this angle over here in red. We have this angle over here in blue. We have this angle over here in green. And we have this angle over here in purple. Now, notice that if you put all of these angles together, since they're all coming out of the same point, what would you expect all all four of these angles to add up to if you added them all together? If you said 360 degrees, you are absolutely right. Let me write add to 360 degrees. And you might have noticed that if you take all the angles together, it kind of makes a circle. Anytime that you have a bunch of angles coming out of the same vertex point, we call this angles at a point because they're all coming out of the same vertex point. They always add up to 360 if you add them all together. So now we can really easily find what the missing value here is because all we need to do is add up the ones that we have and subtract from 360 to find the missing one. So take a second and please do that. And the answer that we should have gotten is 140 degrees. So let me write that down right over here, 140 degrees. The next angle relationship that we're going to talk about are vertical angles. So vertical angles are defined as two angles that are non-adjacent and share a common vertex point. So basically, vertical angles come out of the same point and they're not touching each other. They don't share a common side. They're not right up next to each other. They're disconnected. So if you take a look here in the diagram, these two angles here, I'll highlight them, this angle right over here and this angle right over here are vertical angles because they share a common vertex point. They're both coming out of the same point, but they're non-adjacent. They don't share a side in common. There's no side that is the same between these two angles. They're disconnected. They're not attached to each other. They're not right next to each other. So they're non-adjacent, but they share a vertex point. And if you take a look, we have another pair of vertical angles in this diagram as well. We have this angle up here, and it's coming out of the same point as this angle down here. But the angles are disconnected. They're not touching. They're not right up next to each other. They don't share a side in common. So we can say that these two angles in green are vertical angles as well. Vertical angles are always congruent, no matter what. Vertical angles are really nice because anytime we have them in our diagram, and yes, vertical angles, we can tell from looking at the diagram because of their definition, because they're non-adjacent and they're coming out of the same vertex point. So we can tell from the diagram, they kind of look opposite from each other, across from each other. They're always congruent whenever we have them. So they're a really nice thing to have, especially when we get into proofs after our first test. So they're always congruent. That's why I put congruence marks, the same one, on this pair of vertical angles, and a different pair of congruence marks on this pair of vertical angles. So for example, if this is 100 degrees, this one's 100 degrees as well. And that makes each of these angles 80 degrees so that all the angles can add up to 360 because they're all coming out of the same point. So they should make 360 when you add all four angles together. This question is going to draw upon some of the things that we already learned. So we need to find the value of y, the measurement of y, which is right over here. So let me get rid of this thing for line color. Okay, so all we know is that this angle down over here on the bottom is 140 degrees. But we can figure out some other things because we have a bunch of straight lines going on here, which is really, really nice. So first, let's focus on this line right over here. And that's important because these two angles that are making up the line should add to a specific number if we add them together. Do you know what it is? If you said 180 degrees, you're exactly correct. These two angles are supplementary because they add up to a straight angle. They form a straight line together. So 180 minus 140 degrees leaves us over with 40 degrees for angle Z. Now we're getting closer. Do I have any complementary angles here? If you said angle Y and Z, you would be absolutely correct. Angle Y and Z together should make a 90-degree angle. And also, angle X here is 90 degrees. So that makes angle Y. Can you figure it out? You can either figure it out because we have a straight line here, a straight angle. So angles X, Y, and Z, if you add them together, should give you 180 degrees in total. Or you can figure it out because angles Y and Z are complementary. So if you take the two of them together, you should get 90 degrees. Whichever way you do it, what's the answer? And if you said 50 degrees, you are absolutely correct. Now, it's important to never trust diagrams in geometry because sometimes diagrams can be drawn to be deceiving. So we should always, when we have complementary angles, we should always be given an indication that they do in fact add up to 90 degrees, which this diagram didn't. But on tests and everything, if you're supposed to assume that you have 90-degree angles, they will either tell you in the question that you do have 90-degree angles, that the angles are complementary, or you'll see the little box that indicates that you have a right angle. If you don't see the little box, or if there's no indication in the question that you have a right angle, you shouldn't assume that you have a right angle. So we never trust diagrams. Diagrams can be deceiving in geometry. That's a little side note. The next thing we're going to talk about are linear pairs. So linear pairs are any angles that are both supplementary and adjacent. So they add to 180 degrees and they share a common side and vertex. They're up against each other, they're touching, they're angles that are right next to each other. That's what adjacent means. If you look at the angles A and B in this diagram, they both add to 180 degrees because together they form a straight angle or a straight line. And they are adjacent because they share a vertex and they share a side in common. So we call angles A and B a linear pair. We say that they form a linear pair because they're both supplementary and adjacent. Here we have a theorem that's actually going to become very, very important when we start talking about proofs in about a week or so. And this is the congruent supplements theorem. And what it says is that supplements of congruent angles are congruent. That's a lot to take in at once. So we're going to take a look at the example here in order to really understand what that means. So notice that we have two sets of angles here. Here we have angle 1 and angle 2. And here we have angle 3 and angle 2. So notice that in both of these diagrams, each of the angles are supplementary to each other, meaning that they add up to 180 degrees. They form a straight angle. But notice that both angle 1 and angle 3 are supplementary to the same angle 2. So since angle 1 and angle 3 both form 180 degrees, both form a straight angle with the same angle, there is no choice but for them to be congruent or equal to each other. And to make it a little bit easier for you guys to see, we can use some numbers. So let's say that angle 1 is 100 degrees. Actually, it's probably a little bit better if we give angle 2 a value. So let's say that angle 2 is 80 degrees. So that means that angle 2 here is 80 degrees as well because they're the same angle, angle 2. So since angle 2 and angle 1 are supplementary, since they add to 180 degrees, angle 1 has no choice but to be 100 degrees. And over here, since angle 2 and angle 3 are supplementary, since they add up to 180 degrees, angle 3 also has no choice but to be 180 degrees, so that the whole angle adds up to 180 degrees when taken together. So notice that if you have two angles that are supplementary to the same angle, they have no choice but to be congruent to each other. So once again, we say supplements of congruent angles are congruent. The same thing also goes for complementary angles. So we have a theorem that says complements of congruent angles are congruent. So same exact thing as with supplementary angles, except now we're talking about complementary angles. So instead of adding to a straight angle to 180 degrees, they add to a right angle to 90 degrees. So if we take a look at the example here, we can better see what this means. So notice here that we have two separate situations here going on. And in both of these situations, we have two angles that add up to be a right angle. That little box indicates that we have a 90-degree angle, a right angle in each of these examples here. Notice also that both of these angles feature angle A. So that's the same angle being written in both of these here. So if angle B and angle A are complementary, which they are because they add to 90 degrees, and if angle A and angle C are complementary, which they are because they add to 90 degrees, since angle B and angle C are both complementary to the same angle A, they have no choice but to be congruent to each other. Complements of congruent angles are congruent. And if it's a little bit difficult for you to see and you'd rather see it with numbers, we can do an example. So let's make angle A 30 degrees. So that means angle A over here, since it's the same angle, is also 30 degrees. Now, since angle A and angle B together make a right angle, together make 90 degrees, angle B has no choice but to be 60 degrees to make the whole angle add up to 90 degrees. And over here, angle C and angle A are complementary. They add up to a right angle to 90 degrees. Since angle A is 30 degrees, angle C has no choice but to be 60 degrees in order to make the whole angle a right angle. So we can see that since angles B and C were complementary to the same angle A, they had no choice but to be congruent to each other as well. So once again, complements of congruent angles are congruent. If two angles are complementary to the same angle, well, they got to be congruent to each other. Complements of congruent angles are congruent.